Let us examine this process more closely. The radiated energy can be represented by a traveling waveform of this shape. The waveform normally follows a sine curve. We will consider one complete cycle of the wave. It is defined as one wavelength. We can relate the wavelength of the radiation to the antenna which produced it. An antenna which accommodates half a wavelength is the simple dipole. If we feed a signal to this antenna, an electron flow will be set up within it. The electron flow first produces a maximum concentration in this direction, reverses, then produces a maximum in the opposite direction. Flow reverses, maximum. This cycle repeats itself at the signal frequency. This electron flow creates a fluctuating magnetic field. Let us relate the direction of this field to the electron flow. As the electron flow reverses, the magnetic field is at a maximum, and the lines of force are in this direction. When the flow stops, the lines of force collapse. As the flow reverses, the field again reaches a maximum. The lines of force are now in the opposite direction. The magnetic field thus reverses its direction at each half cycle of the signal frequency. This is known as the H field. The strength of this field is proportional to the amplitude of the current standing wave. This current standing wave is 90 degrees out of phase with the voltage standing wave. At this instant, the antenna has a positive voltage at this end and a negative voltage at this end. When the voltage builds in the opposite direction, the polarity reverses. This changing polarity produces an electric field in phase with it. When the voltage is of this polarity, the field is in this direction. When the polarity reverses, the field builds to a maximum in the opposite direction. This is known as the E field. The E and the H fields thus build and collapse 90 degrees out of phase with each other and constitute the antenna's immediate field. This immediate field produces the radiating wave pattern. From the antenna, we can visualize the radiation